Okay, radioactive decay. So, if we're using Q as our unknown, we can say Q is equal to Q naught. I was going to make a theta there, sorry. Q naught, which is Q sub 0, which means the initial amount. And then we always have 1 minus the rate. And then we have, we've been saying T divided by waiting time. There's different ways you can do that, but if you look at this, what they give us, you can see what shows up for the initial amount. Apparently, the initial amount that they ask for in A, when T is 0, is 25 right there. And it shows up, on the graph that I provided here. And also right there. There's where Q shows up, Q sub naught, the initial value. And I suppose the 0 is for time 0, huh? That's what I suppose. And if we're looking at a half-life, then it's 1 minus half, which means we get half. 1 minus half is half, okay. And they're telling us what the wait time is. The wait time is 1,599 years. Is that all? Okay, so you'll need to graph it to determine, or plug in 1,000 years to see how much is left. There'll be a certain amount left. You could try to read it off the graph. And then use a graphing utility to graph the function over the interval t equals 0 to t equals 5,000. I went ahead and went to 6,000. If you go to Desmos and you see that wrench, you want to click on the wrench. Because if you don't do this, you're just going to get a flat line. It's going to look pretty flat. It's not going to look very impressive. And when you click on the wrench, you get these options. And I go down to the x-axis and I choose 0 to, in my case, I said 6,000. Because I want to see past the 5,000 point. And then it looks like an exponential function. And let me just mention, by the way, that exponential means that you have a variable in the place of exponential, in the exponential position. If you don't have a variable there, you can't call it exponential, and that's what we're looking at. It looks like exponential decay, and it is. When will the quantity of radium be 0 grams? So look at the graph, maybe extend it out to the right, and see when will the quantity of radium be 0, and give me your best estimate at that.